All right, so a couple of examples from chapter 10.1. We're starting to get into graphing equations and evaluating functions. So we're going to graph a linear equation here, meaning a straight line, and then we're going to evaluate a given function for a given value of the input. So when you're asked to graph a function, basically I just want you to understand the Cartesian coordinate system. So we have a graph. This is called the Cartesian coordinate system, where you have x-axis on the horizontal. It doesn't have to be x and y. It can be any letters, but generally we use x's and y's to begin. Point where they cross is 0, 0. Positive x's to the right, negative x's to the left, positive y's up, negative y's down. This point is 0, 0. Every point on this system has an x value and a y value. And that's how we graph points. That's how we graph equations. What did you do with my eraser? Here it is. Okay. So let's graph this given equation. So here we're given a relationship between two variables, x and y. So let's set up a little table here. And we'll put in x's. Sometimes the x variable is called the independent variable, and y is called the dependent variable. Sometimes x is called the input to what we will start calling a function of x. Y is called a function of x because y depends on what x is. Right? So we can choose an x independently, called the independent variable, and y will depend on our choice of x. So generally we start out around x equals 0, maybe go out to 1 and 2, maybe -1, -2, and we see what the y values are at those points. So if we put an x value of 0 into the equation, we see that y is going to be -3 times 0 plus 2, or 2. That tells us the point 0, 2, 1, 2 is on the graph. We'll label them after we plot a couple points so I don't get in my own way trying to draw things. Get rid of that glare a little bit. And let's go out to 1. We put 1 into the equation. -3 times 1 is -3. -3 plus 2 is going to give us a -1. So now we know the point x1, y -1 is on the graph. -1. Just put 1 and 2 there to show the x's. -1 and 2 up here on the y-axis. And let's go a couple more just to be sure. Let's say -1. At -1, -3 times -1 is a +3. +3 plus 2 gives us 5. So -1, when x is -1, y is a +5. Right? And notice those points are on a pretty much straight line. Now, my graph isn't perfect, but let's label those 3 points. Say -1, 5. That's this point. 0, 2 is that point. And 1, -1 is that point. And then we can draw a straight line through those points, pretty straight, almost straight. Arrows on the end to show that that line goes down to infinity, up to infinity. Label at least a couple of points on the line. We had 3. And that's graphing an equation. And so realize every single point on this line satisfies this equation. At any point, infinite number of points on this line, all of them make this equation true. We just chose a few x's, got a few y's, plotted those points. We know it's a straight line. because both x and y are raised to an exponent of 1, right? We don't see the exponent of 1 on the x and y, but we know it's a 1. And when that's the case, we know that's going to be a straight line when we graph it. So this is the graph of this equation. And you can check that on your calculator and make sure that it all makes sense. Right, then we also want to be able to evaluate a function, something like this. We call this P of n, right? P is the output, n is the input. It's like here, x was the input, y was the output. Here, n is going to be the independent variable, and capital P here is going to be the output of the function, or the dependent variable. So we're asked to evaluate this function, find what P is when n is -3. So all we're doing is plugging in -3 into that expression and finding out what P is. So we're going to say P of -3. We're going to put a -3 everywhere that we see in n. So we got -3 squared minus 4 times -3 minus 7. All right, so here's where the common mistakes are in here. People will want to say this is -9, but you got to be careful. When you're squaring a negative value, the negative value times a negative value is always going to be a positive value. So a -3 times a -3 is going to be a positive 9. And we're subtracting, remember your order of operations here, we're subtracting this product. This product is -12, 4 times -3. We're subtracting that -12, so we're adding 12. And then we have that -7 over there that we cannot ignore. Now we're just adding these numbers together. We got 21 minus 7, which leaves us with 14. All right, so that tells us that this function P, when evaluated for an input of -3, gives an output of 14. So if we were graphing this function, the point -3, 14 would be on the graph. If we had P as the output and n as the input. Right? The point -3, 14 would be on the graph of that function. And if we wanted to know the shape of the graph, we would choose a couple more n's, put them into the function, graph those points, and draw it. Now you can do that on your calculator if you wish to, but for now, we were just asked to evaluate this function for n is -3. We did that. We put -3 into the function. We evaluated it and came out with an output of 14, which tells us -3, 14 would be on the graph. All right, so that's a couple of quick examples from 10.1.